Happy Monday, fifth graders. Sorry, my video is a little dark tonight. It's late. I had a fabulous weekend. I hope you guys did too. So I am just here late night making your video for tomorrow. Today we are going to start lesson 2.1 or investigation 2.1 or 2. It is about making similar figures, and you're going to meet the mugwumps today. They're very popular figure in the CMP books. So let's get started. In investigation 2, we're still talking about similar figures. Zach and Marta want to design a computer game that involved several animated characters. They ask Marta's uncle, Carlos, a programmer for a video game company, about computer animation. Carlos explains that the computer screen can be thought of a grid made up of tiny points called pixels. To animate a figure, you need to enter the coordinates of key points of the figure. The computer uses these points to draw the figure in different positions. If you've ever used Scratch, you may have used coordinates to make the animation move. That's what Zach and Marta are doing. So Zach and Marta's computer game involves a family called the Wumps. The members of the Wump family are various sizes, but they all have the same shape. That is, they are similar. Mugwump is the game's main character. By enlarging or reducing Mug, a player can transform him into other Wump family members. Zach and Marta experiment with enlarging and reducing figures on a coordinate grid. First, Zach draws Mugwump on the graph paper. Then he labels the key points from A to X and lists the coordinates for each point. Marta writes the rules that will change Mug's size. So I'm going to play the lesson video for you now. Oh no. I promise it'll be worth it. Here we go.
When creating motion graphics for a video or a computer animation, programmers need to understand how to place and move objects on a coordinate grid. This allows them to be more creative and efficient. Take this situation for example. When building graphics for a math program, the editor starts with the basic figure placed at the intersection of the X and Y axes. We could simply fade the graphic up like this, but that's kind of boring. Moving the graphics around in space and enlarging or shrinking them is much more visually engaging. Let's start by deciding where we want the graphic to end its movement, say at 100 units from the origin along the y-axis. We can also try some x-axis movement. And after a bit of work, we end up with graphics that are much more interesting to watch. Understanding the X and Y axes on a coordinate grid assists designers and animators in doing their jobs. It lets them have a little fun as well.
Okay. So in our lesson today, you are going to work with Mugwump. Marta tries several rules for transforming Mug into different sizes. At first glance, the new characters look like Mug. They might be mathematically similar to Mug. Some of the new characters are quite different, however. They are not mathematically similar to Mug. To draw Mug on a coordinate graph, refer to the Mugwump column on the table of the next page. For parts 1 through 3, plot the points in order, connect them as you go. For part 4, plot the 2 points, but do not connect them. When you are finished, describe Mug's shape. So that's question A. I'm going to show you what the chart looks like, and then know that I have linked that chart, a PDF copy, in your 2.1 folder. So here it tells you Mugwump is just X and Y. So for part 1, it said to connect them as you go. So plot 0, 1, 2, 1, 2, 0, and then you connect them as you go. Part 2 says start over. So this is a new part of the shape. Part 3 says start over. So you're going to connect these points again. And part 4 says start over. It says make a dot. That means you're not connecting those parts. So that is for the main mugwump. So I want you to make that for question A and then describe the shape. You can see here there is zug, lug, bug, and glug. They each have a rule underneath them. You would fill in the chart, and then you're going to have to plot those points as well. So in question B, it says, use the columns for zug, lug, bug, and glug. Use the given rule to find the coordinate points. For example, the rule for Zug is 2x, 2y. This means that you multiply each of Mug's coordinates by 2. Point A on Mug was 0, 1. So the coordinating point on A for Zug is 0, 2, because 0 times 2 is 0 and 1 times 2 is 2. Point B on Mug is 2, 1. So the corresponding point B on Zug would be 4, 2, because you're doubling the x and doubling the y. That's Zug's rule. Draw Zug, lug, bug, and glug on separate coordinate planes. Plot and connect the points for each figure just like you did for Mug. So if I can get back there, you can see the rules for each of them. And I'm guessing you already know which ones are going to be similar. It says, compare the characters to Mug. Which are the imposters? The ones that are not members of the one family, the ones that are not similar. What things are the same about Mug and the others? What things are different about the characters? And that is your lesson for today. The ACE problems are number 2 and number 14 and 15. I will go ahead and show you inside your investigation 2 where that lab sheet is. I'm also going to put in here graph paper. I'll put a little link here for graph paper in case you don't have a graph paper notebook with you. Don't forget to take the investigation 1 quiz also if you haven't already. Have a great day.